Hello everyone, a very good morning and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year, first semester. Myself Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baruipur. You can personally meet me at my college premises, ground floor physics lab. You can also send me a mail regarding your query and doubt at my given mail address, that is godphysics6@gmail.com and gopal.chakraborty_gcem@jisgroup.org. Students, you can also subscribe my YouTube channel for more educational videos on this topic, basic physics. I have uploaded all the videos as per your State Council syllabus, so you can check or go through that video, and if you feel any doubt, feel free to contact me at my given mail address. Now, the course pages are www.webscte.org and www.webscte.co.in. Students, you can find the syllabus for the subject Basic Physics in the University web page. So, in State Council website, the syllabus is already uploaded. You can download the syllabus from there. The course title is Basic Physics. It is under the category of Basic Science course. It has a credit 3, 2 lecture per week and 2 practical per week. So the course is generally made for diploma degree students of first year, first semester. So all branches except architecture, photography, multimedia and printing technology. So apart from these department, rest of the department have to study this basic physics course for their first year, first semester. So as per our college, so we have only electrical and electronics and communication, these two departments. So these two departmental students will going to study this basic physics course for their first semester curriculum. Today, the topic that I will going to be discuss: elasticity, deforming force and restoring force, elastic and plastic body, stress and strain, Hooke's law, stress strain graph. So these topics are under the unit 2, which is general properties of matter. So prerequisite for these topics are basic mathematics knowledge to solve the problems, knowledge of basic concept of science such as physics, visualization and analytical approach towards the subject is very necessary. The course objectives are: analyze the elasticity property of material and corresponding stress and strain, select proper material for intended purpose by studying properties of material, So after completion of this topic, students will able to analyze the elasticity property of material and corresponding stress and strain. They will also able to select proper material for intended purpose by studying properties of materials. So these are considered to be the possible course outcomes. So students, this is the new class where I will start the unit 2, that is general properties of matter. In my last day class, I have already taken 4 classes. So there I have discussed about unit, dimension and errors. So these are the basic building blocks that you need to know, because on each and every upcoming chapter that I will discuss, units, dimension and error, because unit without unit, a physical quantity cannot be defined. Say you say the length of the material is 2, it doesn't meaningful. Okay, so you need the unit and also corresponding dimension, or if there is some measured value, so you may need to calculate what is the percentage of error in this measurement. So please go through that 4 videos class lessons that I have uploaded. And now before starting the today's class, that I will discuss on the topic basically on elasticity. So what is elasticity? And what are the physical changes that you will able to see naturally? Okay, so I will show you with some examples. So the things that you will able to see in your hand, say some elastic rubber. Okay, so you can stretch the rubber, and if you release it, again it's squeezed. Okay, come back to the actual size and shape. Okay, but when you stretch it, it will be so long in leg, and if you release it, will be squeezed again. Okay, so I can show you an example. Say okay, the football. Okay, and now you see this, I am applying a force. Okay, so as I am applying a force, it's squeezed. Okay, it actual size and shape and size change. You can see here. Okay, now if I release, it again come back to a complete spherical round shape. Okay, so you see, so that means I applied the external force, and if released, again it's come back to original shape. Yeah, say for another, it's a hard plastic ball. Okay, so for these, I apply a force, external force, pressed it, but it doesn't change the size or shape. Okay, this is a hard plastic ball. So why these things have happened? Okay, this is all related to that chapter elasticity. So the force that I have applied externally, that is called deformity force or some external force. So when I apply that force, it due to this application of force, the size and shape of that body of the particle may be changed, or it may not be changed, but it has a tendency to change the size and shape. Okay, and as per Newton's third law, that every action there is an equal and opposite reaction. So some internal force will come into act simultaneously in the opposite direction of that force that I have applied, and try to change the deformed shape of that body, and helps it to come back in the original size and shape. So this happens due to some property, and that property is called elasticity. So the deformity force is there, restoring force is there, and so due to the application of this force, some term is very, very important that you need to know, that is stress and strain. Okay, so I will explain step by step, and you hope you will enjoy the class, because you can relate this class with your daily life practical applications also. So first of all, I will explain what is deformative force. So here, what is deformative force? The external forces acting on a body bring about a change in its state or configuration. So that is your deformative force or deforming force. And the latter is possible when the body is not free to move, but the molecules are compelled to change their position. Such forces are called deforming force. This force brings about a change in length, volume, or shape. I here show you some examples. Say here also, say you may consider some sponge ball or say rubber ball or some sponge sheet. So when you apply external force on it, if the body is not free to move, that means as per Newton's law, if it is free to move, then due to application of external force, it will start to move. It will start to move from one position to another position. Okay, but if it is not free to move, what will happen? It try to change its shape, its size, its length, its volume by reconfiguring the internal molecules positions. Okay, so this force by which you are actually make the particular body deformed by size, shape. So this force is called deforming force or some external force. So this is the cause why the body or the particle is change its size and shape, as I have shown you with some football. Okay, so when I applied the force, what will happen? I hold the ball, that means it's not free to move from one position to another position. So the internal molecules of that ball, or here the rubber ball, is try to change its intermolecular space, size, shape, okay, position. So ultimately it will get squeezed. Yeah, it will be change its size and shape. Okay, so this is the application or the definition of deforming force. Now the most important term, that is elasticity. Okay, so what is elasticity? Elasticity is the ability of a body to resist any permanent change to its when the stress is applied. Okay, so when stress application ceases, the body regains its original shape and size. Different materials show different elastic behavior. The study of elastic behavior of a material is of much importance. Okay, say here I have shown you with some examples. Say first we consider some rubber band. If you stress the rubber band, okay, so you feel it will try to come back in its original position, original shape. Why? As I have told you that due to the as per Newton's third law, every reaction there is an equal and opposite reaction. So when you apply some deforming force, that means you are applied here the deforming force in outward direction, so that the elastic will stressed. Okay, and now due to the generation of internal restoring force. Why it is called restoring force? Because it helps the particle, helps the body to restore its original size and shape. Okay, so due to the origination of the restoring force, it will again come back to the actual shape and size. Here also I have shown you that body of the particle, here you have applied the external force from the downward direction, so internally some force will generate in the outward direction to oppose that causes of the change. Okay, so basically these property by virtue of which any particle or the body try to resist that change in size and shape, that's called elasticity. So elasticity, that is the property of the material. So it will change only you change the material. So in some cases, when you apply some external force, some deforming force, it causes the body change the size and shape. Okay, and if you withdraw that deforming force, or if you withdraw the external force, again the body come back to original size and shape. In case of somebody, it will completely regain its actual size and shape. In some case of a body, say for a soft plastic ball, okay, so if you deformed by applying some external force, if you release it, it will be partially deformed, okay, it cannot regain the actual size and shape. But when you take a elastic band, rubber band or rubber ball, if you squeeze it, if you stretch the rubber band and if you release, it's completely regain its original size and shape. And in case of somebody, it may be also possible. If you apply that force and if you withdraw that force, the body will be remain that permanently deformed. Okay. So these three type of cases is possible. So the first case is where the body is actually completely regain its size shape. So that is called perfectly elastic body. So here as a definition you can say a body is said to be perfectly elastic if it regains its shape after the deforming force is removed. Say for an example, a rubber band. Okay, a body is said to be plastic if it doesn't regain its original shape and size and change its physical state after the removal of deforming force. So that is the plastic body. Okay, so example of nearly perfectly plastic body is a wax, putty, etc. Because when you apply that deforming force, it will completely permanently deformed. Okay, it cannot regain its original shape or size. So perfectly elastic body is that one which is able to regain its original size and shape in a complete way. So as you know, that elasticity is a property of the material. So here also plasticity, that is also a property of the material. Okay, so plasticity is the ability to certain solid to flow or the change shape permanently. Okay, when subject to a stress or of intermediate magnitude between those producing temporary deformation or elastic behavior and those causing failure of the material or rupture. So the body that does not tends to regain its original shape, original configuration on the removal of the deforming force is called perfectly plastic body. So as I have shown you some example here, if you consider a plastic bottle and if you just squeezed it, okay, if you deformed it by applying some force, external force to destroy the bottle, it will change, it will squeeze in a small shape and size. Okay, now if you release it, you see that it won't be able to regain its actual shape of that bottle. Okay, so that is the happen due to the plasticity property, and as the body does not tends to regain its original configuration, so you can say it's a plastic body, or in case of in ideal case you can say it is a perfectly plastic body. So by this property, elasticity and plasticity, you can differ how many types of different materials is there, because as per this property, some materials show you that property by which it regains its size and shape. Some material will show you that it not possible for them to regain its original size and shape. So they will be completely deformed their size and shape if you apply some deforming force, some external force. So only elastic body can regain its original size and shape, either in partially or in full. So here, the elastic behavior of that body can be explained on the basis of spring ball model of the solid. Okay, as you know, if you consider a spring, if you just elast it, so it changes the size and shape. If you release it, it again comes back to the original size and shape. So here, by the elastic behavior of that spring, so by the spring ball model, you can able to describe the behavior, that is elastic behavior of a body of the particle of interatomic force. So the atom in a solid may be regarded as mass point or small balls connected in three-dimensional space through springs. The springs represent the interatomic force. This is called spring ball model of a solid, as shown in figure. Normally, the balls occupy the position of minimum potential energy or zero interatomic force. When any ball is displaced from its equilibrium position, the various springs connected to it exert a resultant force on this ball. So, this force tends to bring the ball to its equilibrium position. So, this explains the elastic behavior of solid in terms of microscopic nature of the solid. So, the corresponding graph shown here. So, first graph is with respect to the position, what will be how the change of interatomic potential energy, and second graph shows the force, change in force with respect to the interatomic separation or position of the molecule, that is R. So, to know the elasticity, you need to know the two terms. One is stress, another one is strain. So what is stress? The stress is straightly defined as force per unit area. But the students, you need to know what is that force. Okay, as I have discussed two forces, one is deforming force, another one is restoring force. So here, when you apply the deforming force, the size or shape of the body will change. Okay, so now internal restoring force will comes into play to change the body to help it regain its original size and shape. So now that restoring force per unit area, that is called stress. So here I will explain what is stress in details, and there are different type of stresses there. So one is natural normal stress, another one is shearing stress, and lots of different types of stress is there. So I will explain one by one. So you just remember that it is not that deforming force per unit area, rather it is the restoring force per unit area is called stress, but as per magnitude both are same. Okay, so only the direction is opposite, because the restoring force will act opposite to the direction of deforming force. So stress is the force acting on the unit area of that material. So effect of stress on a body is named as strain. Stress can deform the body. How much force material experience can be measured using stress unit. Stress can be categorized into three categories depending upon the direction of the deforming force acting on the body. When the deforming force is applied to an object, the object deforms. In order to bring the object back to the original shape and size, there will be an opposing force generated inside the object. This restoring force will be equal in magnitude and opposite in direction to the applied deforming force. The measure of this restoring force generated per unit area of the material is called stress. And it has a unit, as it is force per unit area, so it has a unit Newton per meter square or Pascal. So now stress can be categorized into two defined, that is, one is normal stress and another one is shearing stress or tangential stress. Normal stress are defined, it may be longitudinal stress, volume stress or bulk stress, and longitudinal stress are of two types, one is tensile stress and second one is compressive stress. Now I will discuss the types of stress. So first one is normal stress. As the name suggests, stress is said to be normal stress when the direction of the deforming force is perpendicular to the cross-section area of the body. The length of the wear or the volume of the body changes stress will be abnormal. So normal stress can be further classified into two types based on the dimension of force. So these are longitudinal stress and bulk stress or volumetric stress. So what is longitudinal stress? Say consider a cylinder. When two cross-sectional area of the cylinder are subjected to equal and opposite forces, the stress experienced by the cylinder is called longitudinal stress. So longitudinal stress is equals to deforming force per unit area, that is equals to F by A. So longitudinal stress results in the change in the length of the body, hence thereby it affects a slight change in the diameter. The longitudinal stress either stress the object or compress the object along its length. Thus it can be further classified into two types based on the direction of the deforming force. One is tensile stress and another one is compressive stress. What is tensile stress? If the deforming force or applied force results in the increase in the object's length, then the resulting stress is termed as tensile stress. For an example, when rod or wire is stressed by pulling it with equal and opposite force at both ends. And compressive stress, if the deforming force or applied force results in the decrease in object length, then the resulting stress is termed as compressive stress. For an example, when the rod or wire compressed but squeezed by pushing it with equal and opposite force at both ends. So next one is bulk stress or volumetric stress, that is when the deforming force or applied force act from all dimension resulting in the change of volume of the object, then such stress is called volumetric stress or bulk stress. In short, when the volume of the body changes due to the deforming force, it is termed as volumetric stress. And last one, that is shearing stress or tangential stress, when the direction of the deforming force or external force is applied to the cross-sectional area, the stress experienced by the object is called shearing stress or tangential stress. This results in the change in shape of the body. Now, what is strain? When a body is subjected to a deforming force, a restoring force occurs in the body which is equal in magnitude but opposite in direction to the applied force. This restoring force per unit area is known as stress, and strain is simply measure of how much an object is stressed or deformed. So strain can be written as change in the length or volume with respect to the actual length or the volume. So it will be del L by L, or it may be del V by V, or maybe del R by R. So change in the change with respect to the actual length or actual volume. This is your strain. So the next one is elastic limit. Elastic limit is the maximum stress or force per unit area within a solid material that can arise before the onset of a permanent deformation. So when stress is up to elastic limits are removed, the material resumes its original size and shape, and stresses beyond the elastic limit causes the material to yield or flow. So that means if you apply a force more than, or if you apply a stress more than that elastic limit, so it will be then not possible to regain for that body the original size and shape. It will be permanently deformed. So within that elastic limit, Hooke states that within that elastic limit, stress is proportional to strain, and that is Hooke's law. So stress by strain equals to constant, and that constant is termed as modulus of elasticity, which is only depends on the material. So if you change the temperature, if you change the size, if you change the shape, if you change the length, it doesn't matter. It will depend only the property of the material. If you change the material, then only that modulus of elasticity will change. So this is Hooke's law. Within elastic limit, stress is proportional to strain. Now this is stress strain graph, and that is very important, because the graph you see here, stress is along y-axis and strain is along x-axis. That means strain is the fundamental one, okay, and if you deform the body first, then the restoring force comes into act to regain the original size and shape. So strain is more fundamental than stress. So if you increase the strain, the stress is also increased. That means if you deform the body, okay, slowly, then again the restoring force comes into act in the opposite direction slowly. So the graph is linear, and see A point show you the proportional limit, that is the elastic limit. Okay, so B is the elastic limit or yield point. So that means if you apply a stress up to point B, and if you withdraw it, the body regain its original size and shape and follow the same path. But if you apply strain more than the point B, that means up to point C, it will show now the plastic behavior. That means now there will be a complete deformation of the body. It is not possible for the body to come back with the same path. Okay, so now upper than the point C, again you apply a force. So what will happen? There will be a permanent state of deformation. You see here I show you with some dotted lines. So that portion, that deformation you cannot remove. Okay, it may be partially regain its original size and shape, but not fully. And after point D, it is a fracture point. That means the body will break down if you apply more force over that body. So this stress strain graph is very important, and it will show you strain is more fundamental than stress. So these are the books that you may refer. Evaluation process is the same. You have to appear for a 70 marks end semester exam, and 20 marks mid semester exam, and 10 marks for attendance, assignment and interaction. So students, hope all of you have enjoyed and understand today's class. Next day I will discuss the rest part of the elasticity chapter. Thank you.